more applications of decay. Suppose that we know a piece of equipment was purchased for $250,000. The equipment, again, whenever you buy something like a car, anything over time, initially, typically the value decreases, right, because of usage. So this particular piece of machinery, it's $250,000. It decreases by 12% every year. So its loss of value is 12% every year. And that, again, your car does the same thing. When you buy your car and you drive it off the lot, it loses a certain percentage every year because it's now getting older. All right, so what's R? Well, R is 12%, but remember we write it as a decimal. So 0.12, right? You take your 12% divided by your 100%, 0.12. All right, so R is 0.12. Since it's a loss, we've got to remember to subtract, right? That's the thing you have to remember. So if we're talking value, the equation would be our future value equals our initial value 1 minus r raised to the t. And so in this case, our initial value is 250,000. 1 minus our 12% as a decimal raised to time. And again, simplify the inside. So that comes out to 88%, or 88 is in the middle. We subtracted 12%, and that leaves us with, so that means it's worth if we were looking at the first year, it'd be taking the first year times 88. That's how much our value is after the first year. All right, what's the value of the equipment after 7 years? So time is 7, so you plug 7 into that equation. So you take your 250,000, 0.88, raise it to the 7, and it should come out less than 0.02168.90. Alright, so it's worth $102,000 in 11.5 years. So again, same thing. You're going to plug time as 11.5, and you just leave it 11.5. So future value is 250,000 times 0.88 raised to 11.5. And that's quite a few years later, so it should depreciate quite a bit. And it does. Its value is a little bit less than $60,000, so $58,476.56 and change. So after 11, and again, it should make sense. That's a long period of time. It should have depreciated by a lot because it would have got a lot of use out of it. All right, the second example of declining. Radioactive material and things like that. So whenever you're talking about radioactive material or in this case, it's ibuprofen, the body breaks it down in the bloodstream, metabolizes it, that's what it means. It breaks it down and burns it off. And so that's usually decays at a rate proportional to the size, right, for most people. So and it's usually based on averages. So suppose an adult takes 400 milligrams of ibuprofen. The body is known to metabolize ibuprofen at a rate of 29% per hour. All right. So again, the ibuprofen is decreasing in your bloodstream, in your body, by a little bit less than 30%, 29% per hour. All right. Every hour, that's how much your body breaks it down. All right. So that's R in this case. R would be 0.29. Right, we write it as a decimal. It's a decreasing, so we've got to remember to subtract. The initial amount of ibuprofen, so the initial amount was 400 milligrams. And so find the exponential function that represents the amount of ibuprofen remaining in the person's body. Well, the amount remaining is the future value equals, too many lines. The initial amount times 1 minus r raised to the t. And so our initial amount was 400. 1 minus 0.29 raised to time. Remember, time is in hours. And it matches, right? Each hour, time and hours match up. Simplify inside. It's always a good idea to do that. So take your 400 times 1 minus 2.9. So that simplifies to 0.71 raised to time in hours. All right, how much ibuprofen will remain in your body in 6 hours? Well, you plug 6 in for time. I equals 400, 0.71 raised to the 6th. Should be quite a bit less. 51.24. Is it milligrams? Yeah. Left. Alright, so not a whole lot left. 6 hours, it won't be doing you much good. How much ibuprofen will be left in one day? Now, here you've got to be careful. Time is in hours. They gave you 1 day, and so you've got to remember to convert that to hours. So 1 day is the equivalent of 24 hours. So be careful. Remember, units have to match. My interest rate was 29% per hour. My time is in hours, and so I had to convert my days to hours. And so how much ibuprofen will be left in the body after 24 hours? Shouldn't be a whole lot left. There is still some left, but it's minimal, and eventually, again, the body will break it down to where it's non-existent anymore. So 0.11 milligrams left after 24 hours. So make sure you're careful with the units. I'm going to stop there and pick up the next set of notes in the next video.